Hello, everyone, and thank you for joining today's webinar, What is Virtual Commissioning? My name is Madeline, and I am today's moderator, and I'm joined by Curtis, our master presenter, and Dan, our NX and Solid Edge guru, who will be joining us at the end for questions. We'll go ahead and get started with a quick overview of our agenda. We'll begin with a little bit about Geometric Solutions, who we are, and how we can help you, and then we'll jump into our main topic, virtual commissioning. Our presenter today is Curtis, our Director of Technology at Geometric Solutions. He has more than 30 years of experience in manufacturing technology and has been at the forefront of digital simulation, specifically related to virtual prototyping and dimensional quality. He is recognized internationally as an expert in digital simulation using 3D tolerance analysis simulation tools. He has experience using all the major CADs, PDMs, CAE systems, and multiple digital simulation applications. As you will see, Curtis enjoys the blending of new technology, software, and best-in-class processes, all while driving the need for quality, resulting in the reduction of overall costs. As for a quick who we are at Geometric Solutions, the WALTONEN family is made up of 3 companies throughout the Midwest: WALTONEN Engineering, Independence Tooling, and Geometric Solutions. Our story is pretty simple. WALTONEN develops innovative engineering solutions using Siemens software. We got so good at it, Geometric Solutions started selling the same potential for success in the form of Siemens software. So when it comes to implementing and optimizing these solutions like an expert, we do it every day and we can help get you there as well. Now I'm going to turn it over to Curtis. Curtis, take it away.
So one last thing I wanted to add here, the owner of our company, Lloyd Brown, basically came up with this quote of our ability to successfully partner with our customers come from our experience using the tools. We have hundreds of seats of this software in different forms, and we use it every day. So it helps us be experts when we sell it because we have experts in-house that use it. All right, so let's get into what is virtual commissioning. That's what we're here to talk about today. So according to the Tech Clarity Survey, nearly 2/3 of your commissioning time is spent fixing errors and testing, the control software when the hardware has already been assembled on site. So that's a lot of time, 67% spent testing and fixing errors. If we look at a calendar, and if you had like a 3-week launch for your commissioning of your products, that means 2 weeks of those are wasted fixing errors. And what we want to do is see how we can get that back. We want to gain that time back and make it value added to the program. In essence, it's all about time, and time is money. A lot of our customers, when I said 67%, we have quite a few we've talked to that are in the 60 and 70% range. We talked to one 2 weeks ago that figured they were in the 95% range, where they were spending time fixing errors. They said it's very rare that they actually go to a launch and have error-free code. And when I say very rare, once every couple of years. So they're, it's a critical thing to make sure during commissioning we have, you have code that works. And how can we validate that? Well, that's what virtual commissioning is all about. So before we talk about virtual commissioning, we want to talk about how we get there and how this can happen. And it's all about digitalization. It's changing everything. The ways we stay informed, the way we travel, the way we buy things. It's changing business models. The pace of innovation and the ability to disrupt are becoming key success factors in global competition. This increases the pressure on enterprises, no matter what the industry, and opens up new business opportunities at the same time. So, if we look at how this has changed different industries, the way we read books, the way that we listen to music, the way we look up people and businesses' names and contacts, how we travel, where we used to have taxis. Now everybody's doing ride sharing. It's totally changed. Digitalization has changed those industries, and it's changing the manufacturing industry too. If we look at the way that we used to engineer projects, it was all manual. It was, we moved into CAD, but once we moved into CAD, there's other tools. We have simulations tools that do computational fluid dynamics to just make sure the fluid is flowing as efficiently as possible, structural analysis, all types of tools that help engineer better products. The way that we do verification and testing, and this is my favorite slide of the whole presentation here, that group of people standing up on that boom there, just it's an accident waiting to happen, but that's how people in the past have tested things. Now we're using simulation to test things. We're doing it better. We're using tools that can analyze stuff that we never could before. Assembling, we used to do it all by hand, but now between robotics and other tools, automation that will give us lift assist to move things, it is a different ball game now. Manufacturing production, how we make parts and how it's routed through the plant and how automated it is, totally different. And kind of what we're here to talk about, commissioning and services. It was all manual commissioning, very labor intensive, and you had to wait until everything was installed on the floor to be able to do it. So what we want to do is real quickly talk about the digital twin. The digital twin is what allows us to do this manufacturing process of virtual commissioning. So what is the digital twin? So I hate reading from the slide, but I'm going to do this one here. It's a digital replica of potential in actual assets that were physical, processes, the people, the places, and the systems, and devices that can be used for various purposes. So we're making a digital twin of the assets, the physical things, the processes, the way that things are being moved through the plant, the people that do it, the tools that interact with it. That's what we're trying to do, is make a digital twin of the plant floor. So let's just talk about different types of digital twins. The way that I see it here is there's three types of digital twins. There's the digital twin of the product, which is the product that you're making. The digital twin of the production, which is the tools and the plant that make it. Then you have the real production and the real product. And then I can have a digital twin of the performance and how well it's performing when it's in production. If we look at the digitalization of that, we can talk between these things once they're all digital. So from the product, I can put specifications into my production environment and give validation or verification back. For my production environment that's a digital twin, into my real production, I can commission it to make sure the electronics are working and it's going to perform the way I expect it to do, and do validation. And then eventually come up with ideal delivery of the real product. Launch it, start a production, and make sure my product is good. Through all this, there's insights from performance and continuous improvement loops, because I have these things talking in a digital way. I have a holistic digital twin. And it's all in one common collaboration platform. If you can do that, it makes everything talk, and I can actually gain insights from the real product up to my virtual, because I'm using a common tool to do it through digital twins. So we start talking about manufacturing to unify virtual and real production. You got the Internet of Things and cloud-enabled things. So what we want to do is take the virtual production and the real production, or the automation of it, and make sure it can talk to each other. So we have a digital backbone that goes through that to make our digital factory. Manufacturing engineering, automation, cloud and intelligence, I can actually do and perform a digital factory before I pour the cement for the floor. So it's great that I can actually test all this stuff out in a digital environment. If I have a digital factory, it allows me to do planning, simulation, commissioning. I can do AR and VR for visualization of the plant. I can do Internet of Things and sensors and make sure we're talking back and forth between tools that are on the plant, and taking that data and putting it into a business intelligence system and actually forecasting and predicting when we're going to have problems. I can scan the plant floor and bring information in. Additive manufacturing, I can have all these things possible with my digital factory. So let's see what this kind of looks like. So a digital twin of the product. So this product in this case is a machine. because it works as well for my story here. But a company makes a machine, so they make a digital product of that machine. In that machine, they can actually do structural analysis to make sure they have the right size structure to it. It's not oversized and they're wasting money, or undersized and it'll break. So they can simulate all that stuff with a digital twin. Then I can have a digital twin of production, actually putting it together, seeing, in this case, I got humans there, digital humans, to see if they can reach it, see if they can, you can see the gentleman on the right needs a stool or a step ladder to get up to the top. I can test all that stuff, make sure it's ergonomically safe. I can develop throughput analysis through my plant to make sure I'm going to meet my production volume targets. So it's a digital twin of the production of the part. And then the performance, I can actually see how well it's going to perform and test it in a digital twin environment. So what we're going to do is talk about a couple of these here, specifically the digital twin of production and performance together. But if I put them all together, I have this holistic digital twin that I can see all this stuff back and forth between the systems, and allows me to create and use to my advantage this modern digitalization of my product to prove out that I'm going to meet my production targets on the plant floor. So what we're trying to do is combine the real world and the automation on the floor with the simulation software in a virtual world. So instead of testing and doing my commissioning on the real product, I want to do it in a simulation and test it against a simulated product. How would that look? Well, let's take a look. Here we happen to have a plant floor that is digitized. It's a digital version of it. I have my robots in this case. I have sensors in there that tell me parts, are in the right location. You can actually start welding it now that the system's transferred in that place. I have sensors on fences. If I open up a safety fence, the line shuts down. I have palm buttons in there for the operator to touch. I have everything I need to emulate the plant floor and all the automation in one digital environment. So, do you have a digital twin for product, production, or performance?
Looks like our top answer is product.
Yep, most people do product. It's been around for a long time. A lot of the simulation tools, I'm going to say finite element is the biggest thing. That it's been around for decades, and everybody uses it, custom to it. But these new digital twins and the environments they have for production and performance is kind of in its infancy in the industry, and we're trying to make sure people are aware of them and how they can capitalize on it. So let's talk about virtual commissioning. But before I can talk about virtual commissioning, let's just talk about commissioning. What is it? It's basically confirming and checking and inspecting every operational component of a project. I'm going to make sure that when I touch a button on a knob, it does what it's supposed to do. If there's safety factors in there, like safety gates, if I open it up, does the system stop? When it stops, how does it reset? If I happen to have parts clamped into a fixture, does the fixture unclamp before the robot rips the part out? So we can test all that stuff. You want to test all that stuff and make sure that's what's going to happen. So I want to test every operational component, not just regular production, but recovery, safety, testing, and it's for every instrument. But we also want it for the complete system. If I have a cell of robots, that it's all working. If I have a warehouse with elevators that are lifting parts up and down to different bays in a high bay warehouse, what happens when the plant shuts down? How does it restart? We want to test all that stuff. So here's some examples of commissioning. I'm going to say the traditional way. So in this case, I happen to have a robot that's actually moving a couple of blocks and components. It's great. So this is my first commissioning test, and I can see everything's going, but as I go to grab this last one, I miss. You know, no big deal. I can test it. I can reprogram it. But that was a minor error that has to be fixed. Here, you can see by that gentleman's look on the left there, this is not the first try at this, and he's hoping that it's going to work. But here we're just doing this little assembly. So I'm taking my parts, I'm putting them together. Everything's going great. I take this last component, insert it on, put it away, and I go to grab my fixture and I crash into it. You know, so in this case, there's no harm, no foul, but you know, here I have a gentleman that's trying to test this six-legged object and commission it, and you can see he had a failure. You know, luckily nobody got hurt. Here we have more of a silly type application, but you know, it is still commissioning. We're doing our first test of this application of whether or not this can apply, in this case, ketchup, but the, you know, in an industrial application, maybe the sealer, the glue, whatever it happens to be to a product. Here, I want to take this canister and put it on that blue circle. That was the goal. I missed, put it on top of one that was already existing, and I broke the part. I mean, that's bad, it's dangerous. At least I didn't break the machine. Breaking the part, you know, at least the machine's there to continue. But here, I have an arc welding application, and I'm going to go pick this part up. And when I go to pick it up with my second robot, watch the part and watch the fixture that it's laying on, the tubes on the bottom. This part swings around, goes to grab it, misses, and crashes. And when it crashes, this little replay here, you can see parts are flying out, the fixture gets damaged. This was a very expensive failure. The other ones I could probably fix with some software. The one before this where I broke that canister, that was, you know, I could replace the canister, but here, this might cost me weeks of downtime to fix this and a few dollars to fix the tooling before I can make my next part and prove out my product and make sure I can actually launch and, you know, fully commission this product. So we talked about commissioning. Virtual commissioning is the process of using simulation technology to test, you know, changes to your plant before making them through the plant. You know, and that's whether I'm retrofitting an existing line or a new line. This way I can avoid the risk of downtime or revenue loss. So let's just talk about that. You know, the last example I showed you where we did the damage to the fixtures, put it down, I can't be running the new product during that time, and there's revenue loss. But at the same time, let's say I go to retrofit a line and I have such serious problems that I can't get it to work. And I was supposed to be down over a 2-week period. And during that 2-week period, I can't fix it. So I have to revert to the old line and back up. You know, that's an extremely expensive thing because now I got to find another 2-week window to go down while I'm fixing my code. So this is, you know, using simulation, I can test all that stuff out in advance, get most of the bugs out, get most of the quirks out of the system, and then at the last moment put it on the floor where it's been proven to work, and I'll just make it tweak to the actual build of the floor and little differences on where they mount things on the floor and such. So let's just talk about design time. And across the top, you know, if we go through a project launch, we go from project planning to project development, eventually go into production planning and, you know, the engineering and execution on the floor. But up front, the process and planning groups here, you know, there's a group that designs the equipment, folks that work on, let's say this is a robotic cell, work cell simulation for the robotics and the controls design. Then what happens is it's usually the equipment gets installed on the floor. They go through and they program the robots, you know, especially if they're doing teach pendants and stuff like that, to make sure the robots are supposed to be doing what they do. And then if there's any problems or installation, things that they can't reach or whatever, they move things and they synchronize the changes between the two. And then last comes in the controls, and they do their debugging and making sure everything works. Once everything's up and ready to go, they can do their tryout and take that time and eventually launch their product. At that point, if I miss that date, my target date, I'm burning money. My whole business plan is launching it on a certain date, and if I delay past that, I'm losing money because my plant's not producing product. I spent all my money. I have everything on the plant floor right here. It's all sitting there. My robots are there, my tools are there, and I'm not making any profit from them. When we start using virtual commissioning in this concept, what we do is we take the equipment design and do the installation, but we can do our offline programming through simulation. We can do our debugging through virtual commissioning, and we're synchronizing these changes at the same time that the installation is going on, or maybe beforehand. And I'm testing all this stuff out, making sure it all works. I still have to do my physical debug on the floor. Nothing's ever perfect, but I can get 95% of it out of, the bugs found and through the commissioning of it virtually versus just being on the plant floor. And then I take the same trial period and I can advance it, and I'm saving and making money because I've made an earlier launch date. I'm ready to go into production earlier. So does anybody out there use virtual commissioning?
Looks like our top answer is not yet, but interested.
No, I'm glad to see somebody out there is actually trying it, which is good. But the big thing is where do you start? How do you do it? There's actually companies out there demanding that this gets done. There's some large, I work in Detroit, I know the auto industry. There's some auto manufacturers that are telling companies, if you're putting machines into our plants, not only do you have to design the machine, but you have to simulate it, prove to me that the simulation works as far as meeting production targets, as far as theoretical, and you must virtual commission it before you put it on. So there's actually some mandates out there that if you want to play with these big companies as a supplier, they're going to force you to do virtual commissioning. It's coming more and more commonplace out there in the industry. And if you don't know where to start, that's where this is a little primer to help you talk about what it is. So with that, what we do to accomplish this goal is we have a mechanical team, a mechanical engineering team. They're worried about the kinematics of the movement of the parts and the mechanical sequences and the layout on the plant floor. And, are they meeting their cycle times because the conveyors are going fast enough, et cetera, et cetera. But they're worried about the mechanical end. We also have a separate team that is worried about the electrical, the inputs, the outputs, the interlocks, the HMIs, safety, diagnostics, right? The controllers are the pieces talking to each other, the safety fences, right? So all that stuff has to be done, and it's usually done by two separate groups, sometimes in two separate buildings, and they, don't talk to each other well. But the mechanical team can actually do a simulation model that can simulate that stuff. And once I have that model, I can then take my code, my ladder logic and such for all of those things, and run that against the simulation model. And I use my simulation model as if it was hooked up to the code, just like it would be on the plant floor with cables, and we make it work. So what we're going to do is that is the virtual commissioning portion of this. So we're evaluating the mechanical and electrical system behavior together to make sure that it works. And so that's the whole goal of virtual commissioning. Simulate the mechanical, add the electrical to it. In the mechanical, we'll have sensors in there. So there's like palm buttons for that operator to hit. The electrical will take those results of that palm button, if it is hit in the simulation, and then act upon it in a code and tell the simulation what to do. So that's, at a high level, what the system does. And really what it's all about is money. Here, we're trying to save money. We're trying to make sure that we're profitable and we're not finding the errors on the plant floor. The plant is a very expensive place to find an error. I'd rather find it in the office and fix it when I haven't cut any metal, I haven't done anything. I can fix it cheap and easy. So here it is in action. On the right-hand side, here's my simulation. On my left-hand side, I have a simulation of my HMI. So I'm hitting the buttons as if I was an operator hitting the buttons, and is it working? So at this point, you can see the yellow flashing light. I'm testing my tools. So if I come over here and put my dumps in, I can actually see it in the simulation. The HMI is driving, or the HMI is driving the PLC code. The PLC code is telling the simulation what to do. This is virtual commissioning. You know, here, if I go back to the main one, it says to load part one. That's the yellow flashing light. So in my simulation, I load my part. I can hit the start button because that's what my HMI is telling me to do. I hit start and it comes in, starts clamping, does a quick weld. Then I have to load part two. Part two shows up. I can hit the start button again and away it goes through and welds it, right? So I'm testing the logic of my code against a simulation versus waiting until I have everything on the plant floor and wired up and put together. So that's what virtual commissioning is. That's simple. Here we have another example. Here I have a little index machine, and you can see I got slides and index table. But on this machine, I have limit switches. I have part presence sensors, right? On the very right-hand side, this gold column over here, I can actually see the status of every one of those sensors that is telling me if it's true or false. It's basically binary, you know, for these kind of sensors. That is an input from the simulation to the PLC code. The PLC code then, based on that input, gives direction to the simulation model to index a table once all those slides and everything and the pick and place objects are in place. Then the table can rotate. So it's following the logic of the PLC and driving the simulation. So and that's what, you know, this whole thing's about for virtual commissioning. Sensors in the model feed the PLC. The PLC reads that information along with HMI inputs and then gives direction to the simulation model like it would on the plant floor for these things to move and operate, to give motion to those slides, turn on a motor, whatever it happens to be. So here we have a little 3-axis machine, but on the left there's the HMI, the virtual HMI that I have. But here we can do riskless tests. You know, here I actually have a part that crashes. It goes down too far. It's screwed up. In this simulation model, it's just electrons. If I was on the plant floor, that's thousands and thousands of dollars and time to fix. You know, it's riskless tests. During the simulation, I can test it and there's no risk to it if I fail. I can also do things like here, I got a pick and place robot that's going in here. I can test that that's acting and interacting with the rest of the system as planned. Here I got a tool changer. Tool changer is going to come in and try to grab this tool. But I can see I'm off, you know, a good distance here. Well, I can stop my simulation, actually take some measurements. So I'm going to take a quick measurement here. I can see I'm almost 20 mils off. I can go to the HMI, change my code through the HMI, and put in the new value and say run it again, and you can see it lines up. So I can do these tests. I can find the bugs. I can find the errors. I can test it for, you know, total system behavior. I want to make sure everything's working. Like here, does the door open up, you know, to allow me to do my tool changing? You know, all those things I can test to make sure that works. So have you ever had a bad commissioning project that made a project launch late?
Looks like our top answer is sometimes, and it took a couple of extra weeks.
Yep, that's quite common. I was recently talking to a large company that programmed a robot, and the robot was near a column, and they used, you know, 270 degrees as a sweep. They had a 90-degree sweep they didn't go to because of the column. And the home position was at 12 o'clock, and the thing would go from 12 o'clock all the way around to 9 o'clock, and I would operate. And they did a test where somebody hit the palm buttons and the robot was at the 9 o'clock position. When they reset everything, the robot, instead of swinging all the way around counterclockwise, took the shortest route to home and tried to go through the column. Those types of things don't always get caught in the programming because it's the odd scenario. It's not the mainstream production parts every day. Here it was, you know, you had a situation that the robot, the whole line went down because somebody opened up a safety fence or whatever the case may be, and how the thing reset was not tested, and they killed a robot and did some damage to a column, and it was quite an expensive problem. And that happens, you know, and with some companies more often than not that they like to admit. So, the goal here is all about winning at business. You want to be the company that wins, right? And virtual commissioning is a plan for winning. So let's take a look at a couple of examples. So here I'm testing, doing a virtual commission for an automation program for conveyors. So let's take a look at this. I'm going to blow this up. So what you see here is a real conveyor system. It's out of Chicago. In Chicago, there's you used to call it the DII. Now it's the MXD, but it's a defense-funded site that does all types of cool things for production. So here I have a digital twin of that conveyor system, and it's running and it's working. And I'm going to take this digital twin, that's a simulation model, a discrete event simulation model, and hook it up to a virtual PLC. So now that I have that, here's my ladder logic that I'm testing on that PLC. So you can see this gate here that I've highlighted. If I look over here on my ladder logic, I can see this is changing up here. So watch next time that changes, and as soon as that changes, it releases a box from the line there. They're stopped and they're paused until that tells me to go, and that's when they release. So I can actually see the ladder logic is driving the simulation. So here I got my HMI. I'm going to zoom into this one corner over here so I can see everything at once. So I got my HMI here, and I'm just going to do a quick little test on there. So I just want a quantity of one. I'm going to sort on a color. So I want to do red because it's the next one coming up. And if I start my sequence, so it's sitting there and I'm waiting to start it, but you see there's a red guy sitting in that queue right here, waiting to go. And once I hit go, it starts it, it hits the light sensor, and it jumps onto the next track. So I'm just doing a sort. Now the rest of them are going through the regular process, but I did a thing that I made it jump. So there's, light sensors in here. So you can see my little Christmas tree here turn green, goes off on a side track. I can work on it, and it's stopping when it hits the sensor. If I hit release it, it then releases it and it jumps back on the track. So I'm testing the code for my HMI along with the PLC against the digital twin of the real production conveyor system here. So here I have a different type of application. I'm going to look at AGVs, and AGVs have some master control systems because you got a control system to tell the AGVs are ready to go, and each AGV has a PLC on it to tell the AGV what to do and how to operate. It's typically the same code on every AGV, but it's a different piece PLC on each AGV, and there's a master one that controls it. So let's look at that. So Siemens has a product called SimMove that helps control it, but I have a project here that has all my code for the individual AGVs in the system. I got a little HMI here that I developed, and I can see it here, so I can see my loops that the AGVs are going to be running on. And I'm using PLC Sim Advanced. It's my communication tool between the product environment in my simulation and the code. Here's my plant simulation model. It's what they call a discrete event simulation model. Discrete event means events have to happen. It has to hit a sensor for it to keep going. And I'm going to start my PLC. Now that I've started my PLC, I can now import, it's going to take a second here, the SimMove master controller. So the way this is set up is I got to import that master controller logic in there, and it now has to be loaded, ready to go. And then what I have to do is go back to my simulation model, and let's see. Yep, so it's green, it's ready to go. I can go back to my model here, and I can go into my, come on, it's just taking a second. So there's my HMI. I can actually see the line. This is what the operator is going to see. I'm going to make the link inside my model here to the code that's running it. and making sure my inputs and outputs match. So what the simulation person calls a sensor versus what the PLC code says is one thing. So we make a match 1-to-1. So now I'm actually running the AGVs being controlled by the AGV master controller and the individual PLCs on each AGV. And I can see it being tracked. So it's matching 1-for-1. I can go into the diagnostic, detailed information about each AGV that's presented to me in the HMI. So I know where it's at, what its name is, what its number is, and I can track all that stuff. So I can actually use AGVs and that complex logic of PLCs and linking them all together and test all that before deployment and make sure everything's working. To the point of, do I have enough, AGVs, including charging? Is there enough time to charge things? One more here, the digital twin action is I got AGVs, but I'm actually this is a hybrid. Siemens has a couple different products, and we're going to talk about this. And the products are for the plant and for the cell. So this one on the left here is for programming by offline programming of my robots on the bottom left, and it's going to do things. And the main screen shows my plant sim model with that inserted into it. So they're both running at the same time. One model's inserted into another. You can see my AGVs are going along, and they're being generated, and they're just starting off, so they have to fill up the system. So, instead of waiting for everything to go all the way around here, I'm going to grab one of these and drag it over. Come on, animation. There we go. It's getting a part loaded on it. And now that I have a part loaded on it, instead of waiting for it to go all the way around, I'm going to grab that, put it towards the end of the line here, and it'll start coming around to the process simulation model. And, they're linked here visually. And you can see now that it's in there, the robots are now launching at the same time, grabbing the part. So I can actually see the bottom left is the detailed one. The upper left is just a graphic to show what's going on. But that bottom left one is what I use to program the robots and make sure everything is done for offline programming. But I can test the PLC code for that cell and the PLC code for the AGVs, which is kind of cool because I can test that, eventually go into the high bay warehouse over here on the bottom left-hand corner and make sure that's all in there too. So this is put the one part on. The welding station on the bottom, you can see it's just getting ready to be done. It only has the one part on there. It's waiting for another part to arrive because it's an index table that needs 2 parts on it. And if my complete line was full of AGVs, that would be great. But I'm going to grab and drag and drop another one over there. And there we go. It has a part. It's going to come around. And as it approaches, it hits that station. The part actually comes in under the safety fence. And the robot grabs the part. And you see on the bottom left, it's going to put it on the fixture. That turntable will spin once it's set on. And the bottom left is actually running real speed. But that'll index around. I can unload that part, put it on the the conveyor behind me, and then I'll be able to ship it or put it into the high bay warehouse or ship it to the truck that needs to go onto. So here I am taking a very large plant simulation model, testing AGVs, and merging it with a simulation model that does offline programming. So it's kind of cool that they have these 2 different types of simulation packages, and I use them both in one model. So talking about that, Siemens has 3 discrete event simulation tools. We got to use discrete event simulations because that allows me to put sensors in there. And the sensors basically say there's a part present sensor. There's a part here. All right, now you can clamp it. That's the way your code works in your automation. Once the sensor says there's a part there, it sends an electrical signal to the PLC. The PLC says, oh, good to clamp, and sends direction back to the clamp so they swing into place and clamp it. So we have 3 tools. Plant simulation is aimed at the plant level. It's great for AGVs, conveyors, warehousing. It can work whether you make one of a kind or thousands of the same part every day. But it's working at the plant level, and it's working on the logistics. It's working on throughput, and we're trying to analyze throughput and resources. How many AGVs do I need? How many workers do I need? Process simulation is at the cell level, and it's really focused on offline programming of the robots for welding, painting, assembly. I can do robot reach studies. I can make sure my robot cell works perfectly. And then the third one is mechatronics concept designer. And I'm going to say it's at the machine level. This has a physics-based engine. When a part falls off the fixture, it actually bounces like it would in real space, kind of technology used in gaming today. That works on, many things, but it's, I can test conveyors inside a part. I can test placing of parts. There's all types of things that I can do at the machine level, but machine level is very small, something that fits into a 10-foot square. Process simulation is a couple of cells. It could be a whole line of welding stations. It could be 100 foot by 10 foot long, and the plant is at the plant level. So here's an example of the digital twin in action and virtual commissioning. Kuka in Brazil designed a line to do roller hemming of doors. So these are car doors, and there's two robots here that put adhesive on the doors or the pieces. A pick and place robot that moves the parts around. These two robots do the roller hemming, and then there's a couple more that do the spot welding. There's one PLC and two HMIs. So what they did was they simulated the model up front, and they create the robot programs and the PLC code, and they debugged it. They added their interlocks and safety. They validated all that stuff through the virtual commissioning. From the time everything hit the shop floor and ready was mechanically there, it took 6 hours to get to full production because they debugged all their code in advance using virtual commissioning. They also estimated they used 30% less engineering time on the first project. Plus, the team didn't get a vacation to wherever the plant is in the world that they're building it. They stayed in their office. They were only there for a couple of days versus a couple of weeks. So, tool is very value added. Here we have one more simulation I'm going to show you. On the right is my simulation. I'm going to connect it to my PLC here. And so you can see on the right, I basically have short conveyor, a long conveyor, a little one. There's spread lines there for sensors. So this is showing me that this box is on the first conveyor. You can see it there. The robot now takes over, moves it. So that's the screens portion here. It's on the middle rack. Eventually it's going to get to the end. The robot now takes over, and then it goes to the third rack. So I can actually see where it is. I can see what's going on. The sensors here are telling me what's going on. So when it hits this line here, that sensor triggers. It knows it's in the robot. As soon as it breaks the plane over here on that sensor, it jumps on. So the sensors are telling the system what to do, and it tells the robots when to launch and actually do the work. But here, I actually forced one to fall on the floor. Well, you can see things turned red. I got a little red light on my machine. I got red on my code. And I'm going to show my HMI. This is the HMI for the system. And you can see a big red thing down there under the conveyor that shows that I have a package down. So, it's showing me that the system is working here. So if I take that package and put it back on the machine, the sensor is there, and I come back to my HMI and acknowledge it. It goes, okay, and then it just keeps moving along. So it told me that I had to do something as an operator. I did it, and I fixed it. So I'm going to have this one fall down onto the floor, so it hits the center, sensor falls on the floor. The HMI is going to turn red. It realizes it didn't get to the final destination point. And that was part of the code, and now that it's at the final destination point, I can see it there on my HMI, acknowledge it. My robot's now going to take it, move it, and then it's on its way into the last station. So, this is virtual commissioning at its finest. It's showing me where my problems are. It's letting me fix it and proving that when I do have a fault, I can recover from. So with that, don't play guessing games with business decisions and ROI. Virtual commissioning lets you figure out your problems beforehand, and I'm not doing it on the plant floor where I have potential for simple failure that just delays time, or catastrophic failure where I break things and it delays time quite a bit.
Hey, Curtis, nice job on that presentation. Couple questions. What type of companies are using virtual commissioning today?
Well, there's quite a few large companies that are doing it. Say some of the automotive companies, some of the aerospace companies. These big companies are seeing the value, and they're actually mandating it in certain plants and certain types of applications. But there are small companies that are using it because controls companies, people that write automation for a living, they are a supplier to somebody who's dividing the line, or the actual manufacturer who's going to make the parts, and they don't want to fail in front of the customer. They want to make sure it all works. So they're doing their testing up front in their office when they know it's going to be good. And once it's proven out to be successful, then when they arrive on the plant floor, it works.
Very good. Another one. So where do we start?
Yeah, that's always a good question. Yeah, what each company is different, what they're trying to do. I'm going to talk about that controls company we were talking about. They're actually working with a company that's doing the simulation for their robots up front. So they're passing that model on to them, and then they're just doing the commissioning portion. Some companies want to do doing the whole thing because they actually design the tool and the automation. So they have to get the simulation tool, develop the model, or pay somebody to develop a model, and then they do the commissioning to it. So there's different levels. If I'm doing large plant deployments, I have to learn one tool. If I'm a company that makes small machines, we use this mechatronics concept designer and do it all in there. And they're actually coming out with a new add-on that, what is it, automation designer, that actually help program the PLC code. So I don't have to be an expert in the controls logic. I can actually use my simulation model to do it. So it all depends on what you're making, what you're doing, and what your business environment is. But talk to us, we can help you.
Very good. And then another question is, in using this software, what's the ROI going to be?
Oh, depends on what it is. If you're a company that, I'm just going to talk about that controls company. They're getting paid a few dollars to write the controls logic and install and configure it. If they delay a plant from launching, I was working, in the past month, I was talking to a very large company that has now kind of made a mandate that they're going to do virtual commissioning, because during the Christmas holiday, they were doing a changeover. So an existing line was running, they wanted to upgrade it to have some new features. They shut the plant down for 2 weeks, and week and a half into it, they didn't have it running. They couldn't get it to work. They actually made the decision to revert back to the original way the thing was. So you took out all the new hardware because the controls weren't working. And that was a multi-million-dollar decision, because now their new product wasn't there, and now they're waiting until they have another 2-week window to put all the tools in and the testing of the controls. So, and they haven't done it yet. Well, I mean, with this COVID thing, it doesn't help. But I mean, here it is, 5 months later, and they're still not there. And it was a new enhancement to a new product. That can be extremely expensive. So it's, it all depends on what it is. But the ROI, avoiding the errors, is what your ROI is. In addition to launching faster. Especially if you're a supplier to another industry, you want to make sure if the company gives you a date, you make it. Whatever that line is in the sand, you want to make it. This helps you make it on time or earlier, because I'm not fighting my problems on the plant floor.
Very good. Well, yeah, great job, Curtis.